Hello and welcome to Triangles again. This time we're talking about what's called the triangle sum theorem and the exterior angle theorem, which is basically talking about triangles and the measure of their angles. The first part of this will hopefully be a review. It is the most stereotypical thing about triangles that people know. But, if you don't know it, then this is your quick lesson on it. So the triangle sum theorem, it says the sum of measures of the angles of a triangle is always 180 degrees. Boom. And that's just the end of that part. Excuse me. So the measure of angle A plus the measure of angle B plus the measure of angle C altogether is always going to be 180 degrees. That is just a fact. It does not matter what the triangle looks like. If it has three sides, then its angles add up to 180 degrees. End of story. The exterior angle theorem says an exterior angle is formed by extending any one side of the triangle. So like if I felt like it, I could create an exterior angle just by going like this. And then magically this right here is called an exterior angle. Kind of like if I was to rotate the page for a second, you can see it kind of looks like the one over there now if I decided to put an arrow or something. This is an exterior angle from this triangle. So the triangle, then I extended this. This is an exterior angle. Or if I wanted to do one like that, I could change it again, perspective, and you could see this is an exterior angle. Or if I wanted to do like this, then this would be an exterior angle. Or if I felt like doing this, then that would be an exterior angle. Right there, right? This could be an exterior angle from this triangle, or this could be an exterior angle from that triangle. So it's just extended anyway. Technically this one I could have extended this way, and then this would be the exterior angle, but this is just an example. An exterior angle is formed by extending the lines, and what happens is that it is the sum of the other two. So this exterior angle is actually equal to the measure of angle 2 plus the measure of angle 3. So that, once again, is something that is true. If you care about the reason why, I'll tell you right now. Otherwise, you can just kind of, ignore me for a couple of seconds. But the reason, these 2 points, they're called satellite points. I don't think that's part of the curriculum anymore. But this is the adjacent angle. These are called satellite points or satellite angles because just like satellites in the sky, they're far away. So these are the angles far away from it. But if you remember in a triangle, we just said how they add up to 180. So if you completely ignore this one thing, how would you find it? Well, they're supposed to add to 180. But then this right here is called a linear pair. And if you remember with linear pairs, a line is 180. So if you were to try to find this angle, you would have to subtract it from 180. Right? Because if this is 180, you would subtract this to find that. And here you would have to add them to get 180. So I'm not going super full into math, but I'm just trying to give you the idea that if the way you get this is through adding to 180 and the way you get that is to subtract 180, then those kind of cancel each other out. Adding 180, subtracting 180 kind of cancel each other out, and you would just get angles 2 and 3 are the same thing as angle 1. So I could do a more formal proof than that, but I feel like that's probably enough for you guys to see why that has to be true. Of course, during class, if you want me to do a formal proof, I can. But 2 and 3 together make up the same thing as 1. It's also kind of believable if you look at it. Like this is an acute angle, it's small. This is an acute angle, it's small. So you put a small and a small angle together, you get a bigger angle. This one is obtuse. So, yeah. That's that. After that, we're just going to kind of do some examples. I set up some easier examples on the back of this that I wanted to do first with the triangle sum theorem, just to make sure everyone's on the same page. So like if you have 3 angles in a triangle, which you always do, and you have 2 of them, then the way you set it up is 65 plus 25 plus x equals 180. Right, those 3 angles add up to 180. Which you could add these together. That's going to be 60, 70, 80, 90 plus x equals 180. Subtract 90 from both sides and you get 90 is equal to x. And you'd be done with that. This one we would be looking for angle 1. It's just called angle 1 here because I labeled it with a 1. So this little box here means it's 90 degrees plus the labeled 40 degrees plus whatever that angle is, right, is equal to 180 because it's always equal to 180. So 90 plus 40 is 130 plus the angle equals 180. And you would subtract 130 from both sides to get 50. So the angle is 50. So I would write angle 1 is equal to 50 degrees, or the measure of angle 1, like that. So that is one way to do it. If you are an algebra person, that is the equation you set up. Angle 1 plus angle 2 plus angle 3 is equal to 180. The other way to do it, I'll grab a calculator, is that you can actually start with the number 180. And then since the whole thing is 180, you can subtract these parts. So minus the 25 minus the 65 would go ahead and get you the 90 that we got. And same thing over here, you know you start with 180 degrees, you get rid of this 40 degree angle, then you get rid of this 90 degree angle, and you get the 50 degrees that we got there. So you're still, just doing the whole subtracting from both sides. It's just you're doing it in kind of one go. You're subtracting the 40, then the 90. It's a different way to think about it, but it's really the same thing. Okay. So onward to these examples. As you can see, these ones are definitely like more high end. So I'll be walking through these. Excuse me. So in this one, it says to find the missing angle. To be quite honest, like in problems like these problems will end up on the SATs as well. And it's usually easiest if you just find everything possible first and then look at the question. Usually, in math, we're like, make sure you read the directions and make sure you answer the question as it's asked. But with triangles, it's usually easiest to find everything possible first and then just go back and whatever they're asking for, you fill in from your picture. The reason for that is because if you start by, like, if this question just said find angle 3, and you like, well, how do I find angle 3 given these numbers up here, you might start getting confused about how to get there. It requires more critical thinking to say, well, what do I need to use? What do I need to find? Because keep in mind, if it was just asking for angle 3, it wouldn't label these things. It would only give you those ones. And that's more of the SAT type question, where you have to know what to do with these numbers. Do you need to find this angle or not? Do you need to find this angle? Do you need to find that angle there? Well, it's already labeled. But you don't know if you need them. That's why it's an SAT-worthy question. Which is why it's always easiest just to find everything and then to see what they actually wanted. So let's just pretend we needed to find everything. And it turns out in this case we do, but whatever. The first thing I would do is just ignore this. This is a regular triangle. It has 2 angles, so we can find the third. I personally like the subtracting from 180 technique, so I'm going to do that, especially when it's only numbers already. Also, I'll subtract 61, and I'll subtract the 68. And I'll find that this is equal to 51. So this is 51 degrees. 51 degrees. Okay. Next up, looking at the figure, this is a vocab word right here, this angle and this angle right here. So take a moment, see if you can remember what those angles are called. Positive necessary. Now I'll tell you, they're called vertical angles. Now that I've said they're vertical angles, do you remember the relationship between vertical angles? The answer is they are congruent. So if this is 61, this one is also 61. So we know all three of these angles, and we know almost all three of these angles. This is 90, this is 61, and this is the last angle. So I'll do the same thing. We have a full triangle. I'll get rid of the 61 degree. I'll get rid of the 90 degree. So the only space left for angle 3 is 29 degrees. And that's literally everything you can possibly find. All three angles here, all three angles here. Technically, we could find these ones here. You would just subtract from 180. You know, if you felt like getting the practice in, it's a linear pair. So 180 minus the 61 is 119. So if you ever needed that, you could get the 119. But we'll just go ahead and fill in the blanks now. This is 51 degrees. 2 was 61 degrees, and 3 was 29 degrees. Okay. Example 2. Oh boy, we have a bunch of x's. Well, because of that, you can't really do the 180 minus trick because there's x's, there's not numbers. So you have to do the whole, all three angles add up to 180. All three angles add up to 180. So this plus this plus this equals 180. So 9x minus 8, x plus 10, x plus 2. All three of those together have to make up 180. So you solve for x. The way to solve for x here is that then since they are on the same side of the equal sign, you are combining like terms. A 9x, an x, and an x. So that's 9x plus 1x plus 1x. So 9 here, 1 here, and 1 here. It makes a total of 11 x's. And then this is a negative 8, a positive 10. I know that's hard to see, so I'll write it. A positive 10 and a positive 2. So a negative 8 plus a 10 is a 2, and then a 2 plus 2 is a 4, equals 180. So then subtract 4 from both sides, you get 176. And then I'll do 176 divided by 11, which is exactly 16. There we go. Notice in this question it didn't actually ask for any of the angles, so I still have no idea what the angles are, but we do know that x is 16. If you did need to know the angles, you would just take x and you would plug them in to all three places, and you would have the angles. For number 3, there's two ways to do number 3. The first way is to use the exterior angle theorem, which says angle 1 plus angle 2 is equal to 104. That's the whole exterior angle, right? This angle plus this angle equals that angle. That's the exterior theorem. So the 79 plus the 1 equals 104. So you would subtract 79 from both sides. And you get 25 degrees. And that's way number 1. Way number 2 is more roundabout, but if you forget about the exterior theorem, which, you know, is a legit thing. This is a lot to remember, so if you forget that those two add together, no big deal. What you can do is still just find this angle right here. Because they are a linear pair, 104 plus this has to equal 180. So you can say 180 minus this 104 is going to give you 76. So this has to be 76 degrees. Right? So you just found this because, you know, ignoring everything else, if this is 104, that has to be 76, so it makes 180. So you found this. So now you have these two angles. So you can find the third by subtracting them from 180. 180 minus 79 minus the 76. And we get 25, which should look, you know, somewhat familiar. Because I literally just wrote it right there. Boom. Okay. So yeah, two ways to do it. This one, we have to go back to the fact that this symbol, do you remember what that symbol means? And why it's important compared to that one? It is because if this is 7x plus 2, this also has to be 7x plus 2. And I'll go ahead and let you know the exterior angle theorem is a lot easier for this one because this is going to be equal to those being added together. So the 7x plus 2 plus the other 7x plus 2 is going to be equal to this thing. The exterior angles, right? These two satellite angles will add together to be this. And it just so happens they're the same. They don't have to be the same, but they are in this case. And other than that, you're going to solve it the same way. These x's are on the same side of the equal sign, so you put them together. 7 plus 7 is 14. And 2 plus 2 is 4. In the next step, the x's are on opposite sides. Since x's are on the opposite sides, you can either subtract 14x over here or subtract 17x over there. It does not matter which. I'm just going to go ahead and subtract 17 so we can keep x on the left side to get negative 3x plus 4. And then subtract the 4 over to get negative 27. It's negative 3x. And then finally you divide by negative 3. And x equals 9. Don't know how much went off the page there. There we go. That's that. So this is algebra. The big thing is setting up the equation. And once again, it's not asking for the actual angles. You could plug the x in to find what the angles are, but you don't have to. So, yeah. Okay, that's it for this. Hopefully it makes sense. And everyone have a great day. Bye-bye.